Drew says, I would love to see your home presentation setup. So I'll give you the tour while, oh, Gianluca's setting this stuff. Remind me of the next, well, I'll give it to you now. So I have, shooting down from above, so this is main monitor, so I look out at, basically I move this around between you guys, Slack, Twitter, mail, all kinds of stuff. I have a separate monitor. Usually I have all kinds of things over here, but I just didn't want to left and right my head all the time while we're doing this. I have another laptop here that has the rolling slide deck for GroupBy, so that is just what I make the presenter during the breaks. Joris says he's on camera, so I guess I have to put him on camera there. Then I have leaning back a little bit, so I have that's the microphone that you see me using, the Oracle hat that I threw on in the last session. Then I'm looking over at my big wall in front of me. Here is my light. I only need one light today. When I do after hours, I need a couple of lights. A spare set of wheels for my Audi. Working on, I need to get those sold one of these days. They're RS6. Why does that seem so odd now? Oh, I guess because I haven't made it small. Blarg says, love the asteroids, but I don't see the ship. I've actually got ships right in the middle. So the ship's right, I may have to move a little there. And Gianluca is here. Howdy, sir. Now, because there's a lag between the two of us, I'll hold the questions until the end. I won't interrupt you while we're talking here. Because I don't think you're next to me in Chicago. Where do you live out of?
Near Venice.
Oh, wow. That's on my wife's bucket list. She says she's always wanted to go there and Florence. Were you born there or did you move there?
No, I was born here.
Oh, you lucky devil. Do you even know how beautiful it is there or no?
I know.
Explains how your slide decks are so beautiful too, because when you live in a town that beautiful, I guess you just have to have beautiful slide decks.
Oh, thanks.
Yeah. So what do you do for a living?
I'm a DBA. I'm a DBA for Formula One team.
How cool is that? And how did you get started doing that?
Oh, it was by chance. The IT CIO needed a DBA, and he tweeted about that. So I sent him a link to my CV, and it worked.
Oh, and were you a Formula One fan before you went to work there?
Of course.
Right. It's so
That's
incredible.
the only sport.
It's not as popular in America, but I always talk to database administrators. When you're thinking about what career you want, go follow whatever you love, and they need database administrators. The same thing with programmers. And a friend of mine is a database administrator for a motorcycle company, and he'd always had motorcycles, and eventually just all of a sudden he got the chance to be a DBA for Harley Davidson, and he's like, this is the best work ever. Same thing with people who work at beer companies and wine companies. It's amazing.
Yeah. Well, I don't see the car very often, so from my perspective, it would be the same to work for a sock factory.
Yes. I worked for a wine and spirits company, and because of the regulations in the U.S., we were never allowed to get free products. We couldn't, do tastings or anything. It was pretty tough.
How unfortunate.
Right? Had to go buy it myself instead with my salary. Disappointing. Well, so now we're right at the top of the hour. We might as well go ahead and get started. So in this session at GroupBy, Gianluca is going to be talking about not internals, but infernals, the worst things that you can do to your SQL Server. So Gianluca, take it away.
Okay. Can you see my screen?
Yes. Looks beautiful.
Okay, cool. So thank you. So, okay, in this session, as you said, we won't talk about internals, but the topic is infernals, so all the things that will put you in the SQL Server hell. And before we go, a few words about me. I'm a SQL Server consultant, data platform MVP, and I've been working with SQL Server since version 7, so a long time. And in this way, I had the chance to make a lot of mistakes. And that's a good thing because I can show you all my mistakes. Currently, I'm working as a DBA at a Formula One company, the one with the red cars and the prancing horses. And if you want to read my blog, you can find it at spaghettidba.com. And if you want to follow me on Twitter, my handle is @spaghettidba. Okay, so the agenda for the next 60 minutes or so. First of all, we will see why worst practices, because we also have best practices, why those are not enough. And also, then we'll start seeing what could go wrong in different areas of SQL Server, so design, development, installation, and administration. And as you said, it's a lot of topics. I will cover lots of things. So I won't go into deep details of these because we have lots of things to see. So before we go, a little word of warning. Not everything is black or white. So there's lots of gray in this, and most of the time it depends is the right answer. And if you see listed here as a worst practice something that you are doing, don't get mad, because maybe it's the right thing to do in that particular situation. So it's not a thing of black or white. Chances are that if you see something here, it is really a bad idea, but let's pretend that you're doing that in the right situation. Okay, so let's go. Why we need worst practices? Because, you know, we have best practices. Why those are not enough? Well, let's face it, there are too many. It's impossible to know them all in all the deep details that are needed to master each and every topic. And also, there's no time because we have lots of things to do. And there isn't always the time to go and study topics into deep details. So also, when we don't have experience on particular topics, we need to know the bare minimum to get running. And also, it's not always clear what happens if we fail to follow best practices. We have lots of white papers that tell you do this and this and this, but they don't tell you exactly what happens if you do the exact opposite. So it's good to know what to avoid. And here, worst practices can help us. And they show the mistakes to avoid. And they give us the chance to learn from somebody else's mistakes without having to do all the mistakes by ourselves. And if we go and take all the worst practices and organize them in areas, we could have things that have to do with design. So the schema design itself, the choice of the data types, things that have to do with the names that we give to the objects inside the database. And then we have development worst practices, things that have to do with the way we set up the environment, with the code itself, so the way we code our queries and objects, and the way we test applications and the database. Moving on, we have worst practices in the installation area, so the way we choose and validate the hardware, the way we install the operating system and SQL Server itself. And then moving on, we have worst practices regarding the way we administer SQL Server, so backup and recovery, security, capacity, performance, and monitoring of SQL Server. So if you think of these areas as circles in the SQL Server hell, we have a complete hell where the SQL Server gods will put you when you do sins against them. So I will be your Virgil, and I will guide you through the SQL Server hell as Virgil did with Dante. When I'm doing this offline, this is the moment when I put on my laurel, but it doesn't work very well online, so I will skip that. I also have a cape to dress Virgil, but it doesn't really work on Webcam, so let's skip this and go straight to the content. So in the first circle, we have the sinners that go under the name of under-normalizers. So what does that mean? We have rules to design a database properly, and these rules are called normal forms. And the sin that the under-normalizers make is not normalizing the schema properly. So let's see these normal forms. Well, there's a lot of normal forms, but to have a database that is normalized, it's enough to have the three first normal forms. Okay, so the first one says that a table should have a primary key and only atomic attributes. What does that mean? Well, a primary key, it's easy to understand what that means. So if we have a table without a primary key, it's a problem. We are violating the first normal form. And it's interesting to note that a table is the physical implementation of a relation in the relational model. So if it doesn't have a primary key, it's not really the physical implementation of a relation, because a relation needs to have a primary key. So maybe it's a physical implementation of a bin, of a bag, or something else, but not a relation. And also, attributes must be atomic. That means that they have to have just a single value. So values with commas, multiple values in a column, that doesn't work. It violates the first normal form. Second normal form says that every attribute depends on the whole key. What does it mean? It means that if we have a table with multi-column primary key, each attribute has to depend on the whole key. So it can't depend on a single attribute or a subkey of the primary key. The third normal form says that every attribute depends on only on the key. That means that if we have attributes that depend on something different from the key, we have a problem. We are violating the third normal form. So to sum it up in a single statement, the key, the whole key, nothing but the key, so help me God, this is an old one. Okay, so clues that we're doing things wrong. Well, data repeating across rows. We have redundancies in this case. Or inconsistent data between tables. We have the same information in multiple places, and we have different information in different places. That's called an anomaly. And then another clue that we didn't do things properly. Data separated by commas. So example, we have an email column and we have something like john@gmail.com and john@business.com. So this is a clue that the cardinality relationship between the entities in the model is not okay. Another clue of the normalization, we have structured data in notes column. Why do I say notes column? Because notes are usually huge columns that can contain lots of text. So smart developers start putting lots of information inside notes column, separate that with vertical bars and commas, and try to parse the data inside notes to use it improperly. Other things, columns with a numeric suffix. Example, zone 1, zone 2, zone 3. That's a huge clue that things are not okay. And in the next circle, we will find those who generalize too much, the generalizers. You may be thinking, but generalizing is a good thing, especially if you're coming from object-oriented programming. You're probably thinking of complex hierarchies of classes and subclasses and specializations, and the more you go deep in the hierarchy, you will find more specialized classes. That's a good thing in object-oriented. It's not a good thing in a database design. In a database design, things have to be specific. Why? Let's see an example with lookup tables. So imagine that you have a schema like this. You have some main entities like customers and orders, and then you have some small entities around here, so countries, states, and order status and order priorities. And these are simply lookup attributes for things that you find in main entities. So, example, a country here has a country ID. It's a foreign key here to the countries table, which only has an ID and a description. And same thing here for the state. So again, you have an ID and a description. And even here on the orders, we have some attributes that are decoded on simple tables with ID and description. So order status, status ID, status, description. And again, priorities, ID, description. So what we have here is one lookup table for each attribute. So looking at this, there's a button. I see ID description. Wouldn't it be cool if I could take this and generalize this design to have a single table to look up all my attributes? Look at that. Isn't that really smart? What we have here, it's a code and a description, and we just have to put a table name as an additional key here, and we solve all these stupid little tables. Isn't it cool? No, it isn't, because it leads to lots of problems. So what we have here is one lookup table for all the attributes. A one true lookup table that is named by Phil Factor. If you know the guy, he came up with this name. So what's the problem with that? You cannot define foreign keys anymore. You have an additional attribute that you don't have in your entities, which is a table name. You don't have it, so you cannot create a foreign key. And you have to use a generic data type for the ID, which will be probably something along the lines of nvarchar some high number, so that it can store as much as possible varieties of data types. And this leads to implicit conversions and huge memory runs because it's a big column. And also incorrect data, because if you want to store here something like dates or numbers, there's nothing enforcing the correctness of the data that you are storing here. And well, you could use some check constraints to help to a point identify which data type we should be using, but really it doesn't work. That's not the way things should be designed. And also, everybody's hitting a single table, so locking is a disaster here. If you generalize even more, there's one of the biggest sin in database design, which is called entity attribute value, and this will give you the instant damnation badge. So what do we have here? We have, again, customers and orders, and then we have something that help us define some dynamic attributes. So what does that mean? We don't store attributes inside the main entities, but we use these complex structure of attribute values to create some dynamic attributes, not in columns, but in rows. So we have an entities table to insert each of the entities we have in the schema. So one row for customers and one row for orders. And then we have a definition of the attributes we could add to this dynamic schema. So let's add here another table to take all the values of the attributes. So we have attribute ID and entity ID taken from attribute names, and ID is the ID of the referencing entity. So the customer ID and the order ID, and then you have the value, which again is nvarchar 4000. Okay, so what's wrong with this? Isn't it smart? Yes, but what we have again is generic data types. So again, varchar 4000 or nvarchar 4000. Again, no foreign keys. There's no way to define foreign keys here. No check constraints because values are by rows, so there's no way to access other attributes for the same ID. So there's no way to create multi-column check constraints. Every time we need to read a value, an attribute from that schema, we have to access the same table, the attribute values table, multiple times. So there's one access per attribute. But, well, there's some advantages to this design. It's a dynamic schema, so there's no need to alter, and that's a huge plus in some situation. Imagine replication or some kind of distributed environments where changing the schema is really problematic. So, for instance, in replication, you have some disconnected subscribers. If you change the schema, there's some changes to the schema that trigger reinitializing the subscribers, which is not always feasible. So it solves a legitimate problem in a terrible way, but a legitimate problem. So what else could I do? On entity attribute value, reporting is insanely hard because you have to join to all these dynamic attributes. So it's multiple joins to the attribute values table multiple times. So it's hard to write. And also, writing to the table is a mess. The application has to.
Hey, Gianluca, you're breaking up pretty bad over there. You may try turning off your webcam. If you turn off your webcam, the audio might be better.
I close the webcam.
Perfect. Okay.
Isn't that enough?
Yeah, I think that's perfect. Yeah, your sound sounds better.
Yeah,
much better.
You said it's beautiful here.
Yes.
I live in a vineyard in the countryside, and the best I can get here is internet by radio. This is not really stable. Okay.
Wow.
Let's try to move on and see if the internet gods help us. Okay, so what I have here is I'm creating the schema. So first of all, I will create the schema in a proper way. So countries and states and order status and order priorities. So all the small tables with just ID and description. And then I insert the values here. So priorities, for instance, I have high, normal, and low, order status confirmed, insert, cancel, and so on. And then I have the customers table. So what I have here is all these attributes. So they are looked up in the small ID description table with a foreign key. Same here in orders. So I have a reference to the order status and order priorities. And this is how a proper schema looks like. So if I want to do the same thing with a one true lookup table, what I have here is I get rid of all these small tables, and the schema I create here is with a lookup table, which has table name, lookup code, and description, and varchar 4000, and I have my check constraint to try to use the correct data types. And then what I have here, I'm inserting all the lookup values inside the lookup table. So everything goes here. What I have the countries and Italy, Denmark, and Slovenia, which maps to what I had here. So you see the difference. I have here this additional attribute, which is the table name. And this doesn't let me define foreign keys. So when I'm creating my customers table, I cannot create a foreign key on this column, right? Same thing here with orders. It's looked up on that lookup table, and I cannot create foreign keys here. But again, I can insert my data, and it looks exactly the same as it looked on the proper design. if we take this a step further, what I have here is an EAV design. So let's have a look at what it does. First of all, I have to rerun this setup. And let's go back here. And now I need attributes, entities, and values. So let's have a look. Attributes just has an attribute ID and attribute name. Entities has an ID and a name. And here, values has a reference to the attribute ID and the entity ID. And here, ID is the ID from the referencing table. So orders and customers. Okay, so let's create this and insert some data. So inside entities, I will have customers and orders. In attributes, I have some dynamic attributes that are not columns in my entities. So example, delivery date, cancel date, email address, telephone number, and window width. And then to insert the values, I will have to insert things like this. So attribute ID, 1, it is the delivery date. It is here, delivery date is number 1. And then I have the entity ID, 2, which is orders. And ID, this is the ID from orders. So it will be order ID 1, order ID 2, and this is the column where the values go. So here I have to insert the dates in some way. Because it's a varchar column, I have to decide a format to store the dates. And this looks like a reasonable way to store dates. But again, there's nothing preventing me from inserting data like this. So February 30, it works, it goes in. Nothing stops me from doing that. So let's do this. Let's insert this data. And what I have here is attributes. Oh, sorry. Attributes. So in this case, what I was talking about, this attribute ID, entity ID 2, so orders, and ID order 1, 2, 3, 4, 7. And this is an invalid date. Good. So let's see what happens when we read this example. For customers, I have to join to the values table a first time to get the email. So I will force the attribute ID 3 for email. And I have to join again to get the telephone, so attribute ID 4. And again, I have to join to values with attribute ID 5 to get the window width. And this is what I end up with, just to query 3 attributes in my schema. So it kind of works, but it's really clunky. It's not a good design. And again, same thing for orders. So I won't repeat here, but you see for each attribute I add here, so delivery date, it's a first join, second join for cancel date. And here, interesting to note, if I do something like this on the date values, so I have a predicate on the value, it doesn't work because there's an invalid date in my data. So if I want to read this data in another way, to have a single access to the values, so no multiple joins to get the data from there, what I can do is I can pivot the data, which is in rows. I can change that to columns. Pivot is a way to do that. So in this case, what I have is that all the information that I had in rows, so one row for each ID, in this case has been turned into columns. So what I can do here is I can join that pivoted data with my customers. So I just have one access to the values table, which is more efficient, and it yields the same results. Okay. And if I want to write to this schema, I can create a view with this definition, and instead of trigger, as Adam did in his presentation a few minutes ago. If you don't like pivot, there is a cross tab, which is an old school pivot. So you have a case expression here to extract the data and change rows to columns, but the concept is pretty much the same. Okay, so are there questions so far?
Nope,
Okay.
nope, you're good. No, you're good.
Good. So let's go back to the slides. Moving to the next circle, we will find the shaky typers. As you may imagine, it's those people who fail to choose the right data types for their columns. So let's see why it's a bad thing. Examples of bad data type choices. Numeric data types for non-numeric data. Example, a VAT number looks like a number, but it's not a number. You don't multiply VAT numbers. Or postal codes look like numbers, but they're not really numbers. Another thing that will get you the instant damnation badge is storing data as very human readable representation, which is what we just did with the dates in that EAV schema. So don't try to save dates in varchar columns. Again, the use of deprecated data types will get you instant damnation as well. So think of text and image, for instance. They've been deprecated since forever. Don't use that in new development. Oh, well, this is an interesting one. Using larger data types just in case, because who knows, this column could contain some insane amount of data someday. This is not how design works. The size of a column is a constraint on the data itself. So use the bare minimum because not just of efficiency, but also for constraining the data in that column. And also, the same applies to the use of variable length data types for fixed size data. Example, VAT numbers are exactly 11 characters in Italy. I have no idea how it is in the US, but in Italy it's 11 characters. So if it's 12 characters, it's wrong. And it can't be 10 either, so it's exactly 11. This is another one that I have seen a couple of times. Storing durations in date-time columns. No, durations are plain numbers. Another thing that I see wrong all the time is Unicode, and this has two phases. The first one is using Unicode when it's not needed. Example, URLs can't be Unicode, so don't store URLs as Unicode. There's really no need to do that. And the other, on the opposite side, there's storing things that should be Unicode as ANSI. So in today's globalized world, even if your application will not be used in foreign countries, there's people moving around the globe. So what if you have to store some Japanese name in your application and you're using an ANSI column? That won't work. Sorry. If you have the same data, the same information stored in different tables, please be consistent. So don't use different data types in different places. That won't help you. So moving on to the next circle, we will find the anarchic designers, those who fail to use rules in their database design. So what we will have here, we'll have no use of primary keys or use of only surrogate keys. Well, no primary key, we already have seen that it's a bad thing because it violates the first normal form. So your table really is something different from a relational table. It's a bag or a bin, but not definitely a table. But the use of surrogate keys only, what does that mean? Well, sometimes I see tables that only have an ID column, and that ID is an identity column or unique identifier column, and that ID is the only key on the table. It's only a surrogate key. So remember that an identity is not the only possible key. A table has to have an enable key. You're not forced to use that key as the primary key. You can use a surrogate, but remember to always create a unique index on your natural key. If you can't find one, chances are that your design is wrong. Another thing that I see all the time, no foreign keys. Well, foreign keys, they're awkward. They force you to do things in a set way, in a forced way. So they're not good. I want to be free to insert the data in the order I want. Okay, go on and do it. And no check constraints, because the application will guarantee consistency. Yes. Okay, that never happens. Also because often the database is a hub for multiple applications. So it's not one application. You have multiple applications hitting the database, and enforcing the constraints inside all the application can be costly and not always consistent. So you better do that in the database as much as possible. Well, wrong data types. We already have seen that. Remember that the data type is the first constraint on the data, so try not to get that wrong. Well, this is another one that I see all the time. The use of null where not appropriate. So if you have all columns that are nullable, it's probably wrong, because some information has to be mandatory on some tables. So everything null is probably wrong. And on the other side, making everything not nullable will force people to start inserting dummy data. So you will have empty strings or zeros or this kind of dummy data. And how can you tell a proper zero from a dummy zero that really means null? There's no way to do that. So use nullable where appropriate and not nullable where appropriate. So moving to the next circle, we will find the inconsistent Baptists. Here is those people that fail to choose the appropriate names for their objects in the database. And what we will find here is lots of Dan people from Hungary. Nothing wrong with Hungary, but it's a nice STR country. The Hungarian notation is also known as tipping. Why? Because with tables is where you find tables named as TBL underscore something. Or it's also known as Volkswagen because of VW underscore something for views. So all this came from Hungarian notation, which was a notation for programming languages which didn't have proper data types. So the only way to identify data types was to put a prefix in the variable names describing the type of the information stored in the variable. So you had str underscore something, I underscore something, and so on. In databases, this becomes TBL underscore for tables, VW for views, and SP underscore something for stored procedures. This is a bad thing because we have the metadata to tell the type of the objects we have in the database. So we really don't need to know what's happening by looking at the name of the objects. And also, chances are that at some point you will have to split a table into tables and expose the original table as a view. So in that case, you will have a view named TBL underscore something, which really is confusing. So another reason to avoid Hungarian notation. Also, don't use insanely short names. If you're old enough to remember AS400 databases, and you had only 8 characters for table names. It's not that way anymore. So if your tables are named something like AK16OF, well, get out of the 80s. It's 2016. And also, don't get over enthusiastic with long names. So don't name your objects like Java methods. You will have to type that in your queries all the time, so keep it as short as possible. This is one thing that happens all the time in Italy. There is schemas with half of the objects in English and half of the objects in Italian. That happens all the time. You don't have that gems in US or UK, but we have that all the time. It's really annoying. Well, the use of the SP_ prefix. This is probably the most well-renowned worst practice regarding naming. SP_, it's Hungarian notation, as we said, and also it's a wrong Hungarian notation because SP doesn't stand for stored procedure, but stands for special. In fact, it refers to system objects, and it has a small performance hit because objects are first looked up in the master database and then in the user database. It's not a huge performance hit, but keep that in mind if you are running that very often. Don't use reserved words or illegal characters in your names, otherwise your querying will be still possible because you have square brackets, but really tough. And don't use system-generated constraint names. If you create a constraint without explicitly naming it, SQL Server will choose a name for you, and it will be a random name. So if you have the same database in multiple places and you have to deploy a script to change something in the database, the constraint will have different names in each different installation of your database. Choose your name up front and stick to that. The worst of all is having no naming convention or multiple naming conventions, which is pretty much the same as having no naming convention. Okay, let's move on to the next circle where we will find the environment polluters. Here are those who fail to set up their environment properly. So instant damnation for those who develop in production. When I do this, when I present this, I see people laughing at this point, but really it happens. It happens all the time, more often than you think. And also, the test environment is not for development. The test environment, as the name suggests, is for testing. And another thing that I see all the time is people developing on a shared database. No, really, there's no reason to do that. Use your own laptop or desktop for development, and nobody else should use the same development environment as you for development. This way, if you do something that breaks the schema, that changes something that you are taking care of and somebody else is not, you're not breaking somebody else's work. And nowadays, machines, desktop and laptops are beefy enough to do that, so don't be worried of local database development. Another thing that I see all the time is no source control for the database. So nowadays, it's easy to put the database on source control. It used to be hard. Nowadays, we have third-party applications to so Redgate and also things from Apex. There's a Microsoft way to put the database under control inside Visual Studio. So choose one and stick to that. Another thing that I see all the time is developing with sysadmin privileges. So imagine this, you start your development on your machines or your sysadmin, and you use Windows authentication from your Visual Studio. So you hit the database impersonating yourself, so as a sysadmin. And you do all the development work. So the application is ready. You go to the DBA and you say, okay, run this to create my database in production so we can use the application. Good, says the DBA. And which permission are required by this application? Oh, well, I have no idea. That's because you used sysadmin and you didn't have to take note of all the permissions needed by the application. So develop your application using a separate login which has no permission and add all the permissions to a role. So when you go in production, you just have to add users to the role. Well, this is another thing. If you develop for targeting a specific version of SQL Server, use that in the development phase. Same thing applies to the edition. So if you're targeting Enterprise Edition, don't develop on Standard and the other way around. Starting from 2016 SP1, this aspect is less problematic, but keep that in mind anyway. Okay, moving on, we will find in the next circle the overly optimistic testers, and these are those who fail to test things properly. So not testing all the code will get you damned. And also, if you test your application, use meaningful data volumes, otherwise you're just testing correctness and not the performance of the application. Oh, well, you will get instant damnation again for testing in production. This sounds obvious, but I've seen that happening multiple times, so maybe it's not so obvious. Not only it can alter production data, but also it interferes with production users, so really don't do that. And another thing that I see all the time is testing in development environment. Usually the development environment is a small database with a few rows, with few fake rows. So it's not good for testing with meaningful data volumes. So it's useful for unit tests at most. So going on, I'm afraid I will have to put some developers to hell. Don't get me wrong, I'm not into the DBA developers wars, but you know, sometimes developers are lazy. So what do we have here? No transactions. It might sound ridiculous, but I've seen this happening. A few years ago, I was hired by a famous shoe company here in Italy to fix their warehousing system. And it was a huge application in VB6. Yes, I'm that old, so it really was VB6. And the first day on that job, I opened up the VB6 project and I searched for begin transaction, sorry, and I had 0 matches in the project. So it's been really, really tough. Okay, no error handling. This happens all the time. And if you decide to handle your errors in T-SQL, remember that error is a thing of the past. Today we have try-catch blocks, so use that instead. Getting wrong isolation levels, again, it's a thing of laziness. Just because read committed is the default, it's not granted that it's the appropriate isolation level for the whole application. So you will have to go up or down in some situations. Remember that no lock means no consistency. So using no lock will not honor locks put by other sessions, but will also not honor locks from your session, which means that you will end up reading rows multiple times or not at all. So no lock means no consistency. Select star, this is a popular one. Select star means that you are pulling for no reason all the columns from your tables, which means that all this data has to travel across the wire, which is typically slow. And means that SQL Server will easily give up on using indexes, because at some point it will have to look up all the columns that are not included in indexes. So it's really a bad thing. And one of the worst ones is using dynamic SQL with concatenated parameter values. And this happens all the time because the lazy developer doesn't want to add a properly parameterized query. So what you end up with is code vulnerable to SQL injection. So because of the 2 minutes you saved by skipping using proper parameters, your code, your whole project, your whole database is now vulnerable to SQL injection. Well done. And another thing that I see all the time is no abstraction layer. Really, do that. It's 1 second. Create another schema with views that map one-to-one to your tables. So when you have to change something in your schema, you will still have a contract with the application. This will make things much easier for you in the future. So use views and functions in store procedure. Don't give direct access to the tables on the application. So let's move on. And at this point, there's no more putting developers to hell. Now it's the DBA's turn. So regarding hardware worst practices, using unbalanced or inadequate hardware for SQL Server. Why is that a worst practice? Because SQL Server licenses cost a lot of money, and putting them into low hardware is really a capital sin. So you will get instant damnation for reusing the commission server for new installations. Why? Because you will have typically slower CPUs, and license costs the same on fast CPUs. You will have less RAM supported, and RAM is one of the cheapest ways to enhance performance without spending lots of money. Regarding storage, one of the worst practices is planning storage with capacity in mind. Generally speaking, big storage is slow storage, so plan your storage with speed in mind, not capacity. This is typically the choice of wrong RAID level. Well, things are changing a lot nowadays on the storage area, because we have all this solid state hardware, but keep that in mind if you're using old style storage, the choice of RAID level. So typically what you want for SQL Server is a RAID 10. In the next circles, we will find the next finish installers. Well, this is easy to guess what that means. So if you have an installation with accepting all the defaults, you will get terrible defaults for SQL Server, which means the data files on the system drive, which is not really what you want to have. And you will have max stop equals 0, so use all the CPUs, and in today's multi-core CPUs, that is a time bomb. And max server memory, all the memory available, which again is a time bomb for systems that are not 100% dedicated to SQL Server. SQL Server will end up using all the RAM, even stealing it from Windows or competing with Windows for the RAM. So really put a limit to that. And another thing that I see is installing unused components. Really, just install the bare minimum that you need. Otherwise, you will have to patch everything. Installing just the components that you need will reduce the surface. And if you can, don't install multiple services on the same machine. Example, the relational engine and analysis services don't go well together. Same thing for reporting services. It's really completely different types of workloads, so don't try to put everything on a single machine. There's also some easy wins on I/O that you really shouldn't be giving up. It's so easy that it's a capital sin to give up on that. Example, well, partition misalignment, it's pretty much a thing of the past. With modern operating systems, it doesn't really matter that much because we have a default 1 meg offset for partitions nowadays. But it used to be an easy win on 2003. And again, using the default allocation unit, it's 4 kilobytes in Windows, the default. And SQL Server usually performs better with 64 kilobytes allocation units. In the next circle, we will have the careless caretakers. This is a pyramid that Brent will probably recognize because I stole it from his website. So it describes what a database needs. At the foundations of your pyramid, you will find backups and then going up security, capacity, performance, and future-proofing. So everybody obsesses about performance, but what really is important is what stands at the foundation of the pyramid. So basically backups and security. So let's start and go through these levels together. So backup and recovery worst practices. Well, having no backup at all. That means that when disaster strikes, you have nothing to restore from. And also, it doesn't hurt only recoverability, but it also hurt availability, because with full recovery, it's a time bomb. If nobody is truncating the logs, the disk where the logs are sitting will fill up, and the database will get halted. And another thing that is really a worst practice is ignoring RPO and RTO. RPO stands for recovery point objective, and RTO stands for recovery time objective. And these two numbers mean the time of work, the amount of work that you are allowed to lose, RPO, and RTO means the time that it takes to restore back to normal. And these two numbers are not your decision. It's a business decision. So don't try to apply a standard policy to all the databases, so it's nightly full backup and log backups every 15 minutes. No, it doesn't work like that. You have to go to your business owner and ask what they need and have them signing that with their blood. Okay. Not testing your restores will get you instant damnation. So it's really, there's no use in having boxes full of tapes with your backups if you cannot restore from those tapes. This is coupled with consistency checks. So if you don't check consistency of your database and you find out that you have corruption and you restore a corrupted database, you're back to the same situation as before. So really, test consistency on your database. When disaster strikes and you run the BCC repair, allow data loss, what you do is exactly what's it on the tin. So you allow data loss, which is instant damnation for a DBA. So what you want to do is restore for a non-corrupt backup instead. Remember that the responsibility of the DBA is to perform restores, not backups. There's no medal for taking backups. There's medals or no damnation for performing restores. Okay, so moving on. Security worst practices. Things that I see all the time. Too many sysadmins. I once went to a customer who had domain / authenticated users in the sysadmin role, which was really, really bad. So that means that the guy answering the phone was a sysadmin on the database. Not really what you want to have. Or everybody who knows a password for SA? This will get you instant damnation. And another thing that I don't like to see is the use of SQL authentication, because it's not as strong as Windows authentication. Why? Basically because of passwords. So SQL authentication doesn't enforce you to have a password policy. You can apply a password policy, but you can skip password policies, which will let you have weak passwords such as 123 or a password, or same as a username. This one, I find it all the time. And so Windows authentication is better in that regard because it forces you to apply a password policy the same as the one you have in your domain. If you have sensitive data in your database, really set up some auditing, otherwise you will get damnation. Okay, so regarding capacity, worst practices in this area, not checking for disk space. That means if you have no space left, the database stops working, really. Test it. And example, you have full recovery and no log backups, that will fill the disk. And if you rely 100% on auto growth, that's not ideal. So what you really should be doing is sizing your database files up front and never touch those two things, auto shrink and auto close. Well, auto close is a different thing. It closes the database when nobody's using it. But auto shrink in particular, what does this do? It tries to free space in the database by moving pages from the bottom of the file to the first hole in the data file. And this creates massive fragmentation. This, coupled with auto growth, will have a database that grows and then shrinks and then grows again and then shrinks. And the effect of this is internal fragmentation for the shrink operation and operating system level fragmentation for the growth operations. So really, it's super bad. Avoid that at all costs. This is particularly important for TempDB, and also database files for TempDB should be pre-sized, and you should have multiple files in order to avoid incurring in latching and striping penalty on your TempDB. It's so easy, and also nowadays with 2016, the installation wizard lets you do this during the installation, during the setup process. So it's really easy to avoid making this mistake. Moving on, regarding maintenance, the worst practice is here, not maintaining indexes and statistics. In particular, indexes require maintenance, but really don't get obsessed about re-indexing, but index fragmentation. Index fragmentation is more important for internal fragmentation, so the space that is wasted inside the index. So you should avoid reading too many pages for the information that you want to read. Nowadays, disks, especially on SANs, are fragmented by definition, so really there's no point in maintaining indexes to avoid external fragmentation. Another thing that I see all the time is the use of catch-all maintenance plans. So what we have is something like this. First of all, we rebuild all the indexes, and then we reorganize all the indexes, and then why not? We update all the statistics, because that's what I'm supposed to do, right? Well, not exactly. Well, first of all, rebuild index. Okay, all tables. Why? When you clean your house, you don't take all the furniture out of the house, clean the floors, and then put the furniture back in. you want to clean just when it needs to be cleaned. The same applies to database tables. So you should rebuild just the indexes that you want to rebuild. Then, when you rebuild the indexes, what you end up with is an index completely rebuilt, so a perfect index with a full statistic, full scan statistic on the index. So there's no point in updated again statistics using a sample, because this task creates a sample statistics, and unless you specify the scan type full scan. But you already have done this, so there's no point in doing that. And obviously, there's no point in reorganizing indexes when you have just rebuilt them. Okay, moving on, in the next and final circle, we find the worst offenders in the SQL Server. Okay, so again, pyramid idea. Bottom of the pyramid, you will find what's most effective when you have to tune database. After that, you find what's less effective. So why we have people working from server tuning and then going back to queries? It's easy. For server tuning, you just have to turn on knobs. But what really helps performance is proper image design and queries and indexes. So the perfect balance for database is index and queries. Design action. So everything you do has to be it is breaking, I think.
You broke up there for a second, Gianluca. Your audio's gone again. You may we lost about the last minute. In case if you've got anything open like Dropbox, you may have to close that.
Oh.
Something just kicked up there.
Oh.
Or maybe the wind picked up at your house.
No, nothing.
All right, go ahead and give it another shot there. Keep talking, we'll see what we get.
So the best way to perform look at the pyramid is to use optimization, because schema design is really a bit too hard to change for any given project. So you should be intervening here carefully, and just locking or server tuning usually doesn't help much. So let's go and have a look at all the different levels. So, well, in query optimization, worst practices. Well, the worst of all is row by agonizing row strategies. So rebar, thanks to Jeff Mullen for coming up with the term. So that means cursors and while loops and upside cursors. So if you're doing your loops in .NET, it doesn't get any better than doing that in T-SQL. There's also hidden rebar, which is scalar and multi-statement functions. That's really bad for performance. Other things that are really bad for query optimization: views and views and views. Why is that a bad idea? Because it looked like a brilliant idea at first, because you reuse all the code. Yay! But there's a catch. You can end up losing control if you have too many views nested. So at some point, you will keep accessing the base tables again, because you don't have that particular column that you need in one of the levels of your views. And so you will have, again, unnecessary joins to the base table. And I see Brent writing, so he's maybe trying to say that my voice is breaking again.
No, your webcam, your voice is fine, but make sure you close my
Oh, okay.
webcam window just so you don't. That's probably what's slowing it down.
Okay. Uh, okay, so what you end up is that you lose control at some point. So you remember this movie, Inception? So you had a dream inside a dream inside a dream. Well, things didn't turn out very well for the characters in this movie, and the same applies to views and views and views. So try to avoid that as much as possible. Okay, so I have a quick demo on views and views and views. Let's have this. So the concept is pretty simple. So you have a view, you create a view on open orders. So this is based on AdventureWorks. And you take these columns. And again, you create another view here. And again, you need to take another person ID from customer. So you have to join again to customer. So really what you end up here is that you query the same tables over and over directly or through the view for no reason whatsoever. So get rid of that and query the tables directly. Okay, so query optimization worst practices. One query to rule them all. I once had to tune some queries which was 2 megs of SQL. That's not fun at all. The optimizer is good. It's not perfect. So when you submit a 2 meg query, it will simply give up and give you whatever plan it can come up with. So in many situations, a divide and conquer approach is much better. Another thing that I see all the time, distinct because why not? Who wants stinking duplicates? Yeah, so distinct. No, really, distinct means that you will have to use a sort to take away the duplicates, and it's really, really bad performance-wise. Or using query hints, because the query hint solved the problem once, so query hints all over the place. Don't use hints, especially index hints, because the optimizer knows better. So don't let the optimizer do its work. And also, if you use index hints, if you rename or remove the index, the queries will stop working, which is not exactly what you want. Regarding indexing, well, one of the things that I see all the time, DTA indexes all over the place. A suggestion from Tune Advisor. Tune Advisor is a nice way to know that things are wrong and there's something to fix, but don't take all the suggestions as gospel. It's an indication that something is wrong, it has to be fixed, but not necessarily in the way the Tune Advisor suggests, because it suggests very often duplicate indexes. Another thing that I see all the time, an index for each column. Yay! So indexes all over the place. Indexes are not for free. They're copies of the data in the column. So really, just the ones that we need. Another thing that I see very often is a suboptimal cluster index. A good cluster index for OLTP is usually unique, small, unchanging, and ever increasing or decreasing, even if that creates an hotspot effect, but it's a totally different topic. Okay, so this means if you're using a unique identifier, use new sequential ID instead of new ID. Okay, regarding server tuning worst practices, throwing hardware at a problem is one of the things that gets you instant damnation. Why? Because a twice as fast machine might make rebar code twice as fast. It really doesn't happen. It could, it might do that, but what it can't do is having 500% improvements that you can have when you change your rebar code to set-based code. So do that instead. And one of the things that really get you damned is the use of advanced options without testing. And there's a couple of settings that really shouldn't be so easy to change. Example, anti-fibers, lightweight pooling, or priority boost. Those really shouldn't be in the instance properties window. So Microsoft, please take them away. Nobody should touch that. So there's no time to go into deep details. I have some resources for you. There's a detailed blog post for each of the circles on spaghettidba.com. Oh, really, there's not at this time. There will be at some point. So there's a few, but not all the circles up on my blog. I promise I will fill the gaps. If you want to analyze your best practices instead of worst practices, there's a tool for you. It's the Best Practices Analyzer, and this is a link to download it. And if you want to contact me, you can send me an email, spaghettidba@sqlconsulting.it, and this is the link to the session, which contains also the link to the demos. And here's a link to my series on SQL Server Infernals. Oh, sorry. So, are there any questions?
Well, you know, it was interesting. You didn't get a lot of questions, but you got so many people saying that they loved this talk, that they recognized so many of the levels of hell inside their own companies. Several people were keeping track of how many circles of hell their companies have been in.
So there's a whole bingo.
Yes, we should have had a high score tracking. Several people say they have all kinds of good things to say about your sessions. One person said their company met all of the circles. James asks, what's the best tool in your opinion for source control?
Well, I tried a couple of them, and I think the best at the moment is what we have in Visual Studio. In SSDT, because it's a declarative definition of the database, and it's not just imperative scripts as you have in other source control tools. So I love that for that reason.
And then JD says, if you're forced to use SQL authentication, what's a good way to minimize the side effects, or is there anything you can do to make it easier or better?
Can you repeat, please?
If they use SQL authentication, SQL logins, is there anything that they can do to minimize the security risks?
Well, the first thing to do is to make sure that you are using the password policies on your SQL Server logins. And another thing to do is to test your logins for obvious weak passwords, such as well-known ones, or the ones such as same as username. There's tools that can help you do that.
Okay, great. Well, thank you so much, Gianluca, for presenting today. This is a huge hit. People love this. Folks, if you want to look at the slide deck, you can go to groupby.org/go/session5, where you can go revisit this slide deck and pass it around with your coworkers, because you're all going to laugh at how many of the levels of hell you're meeting right now. So thanks, Gianluca, and we'll be talking with... Thanks for submitting. This is such a good slide deck. I knew when I saw it I was going to love it.